We have one more example to cover for this section. This is part 2 of 10.8. The system here is a nonlinear system of is a system of nonlinear inequalities. You can see all the three inequalities, all the three things in the system are inequality, and they are nonlinear. This one is not this one, yeah, they are nonlinear actually, technically speaking. They are all nonlinear. We are going to find the solution set for the system. In order to do that, we are going to find the solution for each single inequality and then take the common part. Alright, so let's start from the first inequality. Y squared less than or equal to 9 minus x squared. The solution set gonna be a region in a two-dimensional space. The region would have a boundary. How do we find the boundary? This is the inequality symbol. Change that inequality symbol to equal sign. The graph corresponding to this equation would be the boundary. So let's see what is that. We move x squared over. We have a positive x squared. This is a negative, so we move it over, we have a positive. Positive x squared plus y squared equals 9. Allow me to write 9 as 3 squared. Okay, do you see that what kind of graph this equation has? Is a circle. Yes, this is a circle centered at the origin 0, 0 with the radius. What's the radius? Is 9 or 3? 3. Okay, is the radius 3. So I don't mind we draw the graph here. This is the center. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. And the boundary is gonna be a circle. Hold on. Am I gonna draw a solid circle or dashed? Solid, because the original inequality has the equality in it, is less than or equal to. So we are going to draw the circle solid. Not perfect, but it's a good circle. All right. So this circle divided the whole plane, two-dimensional space, into two parts. Part 1 inside the circle. Part 2 outside the circle. Then which part, which region is the solution? Is the solution set of the inequality number 1? We find the testing point. Okay. Yeah. We're gonna try 0, 0. Choose 0, 0 as the testing point. We are going to plug 0, 0 into the original inequality. Original inequality is y squared less than or equal to 9 minus x squared. If we plug in 0, 0, y equals 0, x is 0, we have 0 less than or equal to 9. That is a true statement. So that means the origin here is a solution of the system. I'm sorry, is a solution of the inequality. So the region is gonna be the whole circle, the region inside the circle, including the points on the circle. The shaded red region, that's the solution set of the inequality number 1. All right, are we good about that? Let's move to inequality number 2. Inequality number 2 is y less than absolute value of x. Okay. What is the boundary? So after so many times repetition, you should see the pattern. Whenever we need graph the solution set for an inequality, we start from the boundary. How do we find the boundary? Simply change the inequality symbol to equal sign. That is the boundary. Boundary of what? Boundary of the solution set of this inequality. Okay? Let's graph it. Let's graph it. How do we graph it? And this function actually is piecewise. It is piecewise. As x bigger than 0, y equals x. As x equals 0, y equals 0. As x less than 0, y equals negative x. For example, if x equals negative 7, then what's the absolute value of x? We know that is a positive 7, right? So the absolute value of a negative number happens to be the opposite of x. The opposite of x, which is the opposite of negative 7, which is a positive 7. I want you please repeat this part to really understand how come as x is a negative, the absolute value of x is the opposite of x. Opposite of x here is a positive because x is a negative. So the opposite of x is a positive. Very important and basic. Let's graph this piecewise function. That's the reason in the beginning I say the inequality is not linear because it's piecewise. Linear equation corresponds to a straight line, but this one you would see it is a, how do I say that? Is a piecewise. It's two rays actually, two rays. So let's graph it here. Let's graph it here. As x, this is a y, 0x. As x equals 0, y equals 0. So we know the origin is on the graph. As x is a positive, y equals x. So in quadrant 1, we would have y equals x. So that is this ray. Technically, that is a ray, right? As x is less than 0, corresponding y value is the opposite of x. So y equals negative x. Y equals negative x has a slope negative 1, so it's going down. Is this straight line? Okay. Another way to graph the boundary is, you know, in quadrant 1 is going to be a straight line, right? You can try to let x be 1. If you let x be 1, y equals 1. So you have 1, 1. That would help you to draw this ray. And in quadrant 2, if you let x be 1, y would be negative 1. 1, negative 1 is here. That would help you to draw the ray in quadrant 2. All right, so that's the boundary. By the way, am I right? I draw the boundary as a solid line. I wanted to show you clearly the boundary, but actually we're supposed to draw a dashed line here. The reason is because the original inequality has no equality in it. It's strictly less than. So we would have to draw the boundary dashed. Let me do that again. That indicates the points on the boundary do not belong to the solution set because they do not satisfy the solution. They do not satisfy the inequality. All right. So dash the line. Dash the line. Again, the boundary is dashed means the points on the boundary are not the solutions. For example, earlier we have this is a 1, 1, right? Is on the boundary. But if we plug this point back into the original inequality y less than absolute value of x, we would have 1 less than 1, and that is a contradiction. Am I clear about that? So the boundary in this inequality, in this case, has to be dashed. Okay, so you see the boundary divided the whole plane into half. One part is the region above is a cone region, right? The other part is the region below. So which part is the solution set? Testing point, yeah. But this time 0, 0 is not working anymore. We would have find another point, maybe try 0, 1. Any convenient number, any point, any point with convenient coordinates would be okay to be chosen as the testing point. So we plug the testing point 0, 1 into the original inequality, which is y less than absolute value of x, y equals 1, x equals 0. Is that true statement or a contradiction? 1 less than 0 is a contradiction. So that means 0, 1 is not a solution. 0, 1 is not a solution of the inequality number 2. Then that means we are going to shade the region below the boundary. All those points, they are the solutions of the inequality. Okay, of course they are extending indefinitely. Is that clear? Number 3, inequality number 3. Let me see, what is it? It's y bigger than negative absolute value of x, right? Y bigger than negative absolute value of x. Okay, so that's the third inequality in the system. So let's see, how do we graph the solution set for this inequality? What's the boundary? Change the inequality symbol to equal. This is the boundary. Is the boundary. Boundary of what? Of the solution set, which is a region of the solution set of this inequality number 3. And it is also piecewise, okay? Yeah, negative absolute value of x. Do you guys remember the transformation of functions? Didn't we just graph the function y equals absolute value of x? We know the graph is a V-shaped graph, right? Then what's the graph of y equals negative absolute value of x? We multiply the whole function by negative 1. So how do we transform the graph of this one to get the graph of this one? We multiply the whole function by negative 1. Is equivalent to flip the graph over x-axis. Okay, so we are not going to graph the boundary by using the piecewise. We are not going to graph it piecewise. You can try that on your own, but we are going to graph it by using the transformation. We know without the negative sign, the graph is a V-shaped graph, right? But now we have a negative absolute value of x, so the graph is going to be flipped over, reflected over x-axis. This is x-axis. So it's going to be look like this. Why I'm drawing the boundary dashed? Same reason with earlier. Because the original inequality symbol does not contain equal sign. Means the points on the boundary do not belong to the solution set. Okay, so this V shape, not a V shape anymore. What's the thing? Like upside down V shape graph divided the boundary, divided the whole plane into half. The region above it and the region below it, right? Yeah, we want to know which part is the solution set. So 0, 0 here can't be chosen as the testing point anymore. We're going to try 0, 1. We plug the testing point 0, 1 into the inequality. y bigger than negative absolute value of x. Y equals 1, x equals 0. Negative 0 is still 0. So true statement or contradiction? True statement. So it means 0, 1 is a solution. Is a solution of the inequality. So we are going to graph shaded region above. Okay, the whole region above this boundary, they are the solution. That's the solution set of the inequality number 3. Well, now I'm gonna combine all the 3 graphs together. Okay, I'm gonna combine all the 3 graphs together. Let me see if I can do it nicely. Draw the graph nicely, I mean. 1, 2, 3. 1. I have a nice graph in my notes. 1, 2, 3. -1, -2, -3. 1, 2, 3. So firstly, I have what color? Let me see what color did I use in the notes. I wanna maybe be consistent. I think I used the gray. This time I'm gonna use blue for this. Blue for this circle. Remember the solution set of inequality number 1. Yeah, this is blue, right? I want a darker blue. Let me see this one. That would be okay. Yeah, the same color, similar color. So this is, hold on. This region, again, including the boundary. That's the solution set of the inequality number 1. Oops. Right? And the inequality number 2. Inequality number 2, what color do I want to use? It is dashed, remember? Pink, maybe. Let me use pink. Which region? Let me see which region. The region below. The region below. So we're gonna have the pink region below the boundary. Not including. Ooh, it doesn't really working well because the blue is too dark. I would have to change the color here. Change a lighter, like a, that would be this color, still this color. Okay, this color. But I want to emphasize that the boundary of the circle, the points on the circle, are solutions of the inequality number 1. Okay. And then the pink part gonna be the solution set of the inequality number 2, all the points below that boundary. Yeah, I would have to shade all the regions, the whole region. Okay, I think that's good enough. Excluding the points on the boundary, by the way, again, okay? All right, so the solution set of the third inequality. It's above, right? It's above, so we're gonna shade the region above. Which color? Yellow. Let me use yellow here. All those regions. Above the boundary, not including the points on the boundary. Do you think you like the color? I use different colors in my notes, but I think those colors might also work. Okay, so do you think you saw the common part of all the three colors? What color did we use? We used blue, the light blue, this color, and the pink, this color, and yellow, this color. And which region has all the three colors all together? Which region? I give you a little bit of time to think about that. Is this region, okay? It's like a butterfly. This region, I don't know how do I call that color, but that region, like two sectors. That's the solution set of the system. That's the solution set of the system. If I shade it, it's gonna be like that. Okay. And one more thing I want to ask: is a 0, 0 a system? I'm sorry. Is a 0, 0 here, the origin, a solution of the system? It's not, because the origin is the intersection of the two dashed line. Okay, the two lines are dashed because the points on the line are not a solution. Of course, the intersection of the two dashed line, not a solution. And this point also not. This is a circle here. This is also a circle. Okay, because it's on a dashed line. This is also circle. This is also circle. But between the two circles, this arc, those points are solution of the system. Am I clear about that? All right, so that's the solution of the system of nonlinear inequalities. All right, I hope you can repeat those examples. If you have any questions, please feel free to make an appointment with me. I hope to see you soon in Zoom. Thank you for watching.